Welcome everybody to this new lecture of our paper Waves, Oscillation and Acoustics. Today we will discuss another new topic of our syllabus, that is about superposition of two collinear harmonic oscillations, or you can say it as oscillation having different frequency, or you can say it as beats. Okay. इससे पहले वाले लेक्चर में जो हम स्टडी कर रहे थे वो ऐसी सुपरपोजिशन हमने स्टडी किया था ऑफ टू वेव्स विच हैव equal frequency, or you can say it as equal time period or equal wavelength. Okay, so why that wave must have equal frequency, but the waves are differ in amplitude and in phase. Okay, have different phase or slightly different phase respect to each other, and but have same frequency. But in today's lecture we will discuss about the superposition of two collinear harmonic oscillation, or oscillations having different frequencies. इससे पहले वाले टॉपिक में हमारे पास जो ऑसिलेशंस का सुपरपोजिशन, हमने दो हार्मोनिक ऑसिलेशंस का सुपरपोजिशन पढ़ा था, उसमें हमारे पास दो ऐसे हार्मोनिक ऑसिलेशंस थे जो इक्वल फ्रीक्वेंसीज के. लेट अस सी दैट. ये हमारा टॉपिक था इससे पहले, दैट सुपरपोजिशन ऑफ टू कोलिनियर हार्मोनिक ऑसिलेशंस. ओके, दैट इज द रिजल्टेंट ऑफ टू SHMS in the same direction. Okay, and इसमें हमने ये कहा था कि consider two simple harmonic waves with same time period, that means same wavelength and of same frequency. But in today's lecture we will discuss another topic in which the two harmonic oscillations, the two collinear harmonic oscillations have different frequencies. Okay, so let's see it. When two sounding bodies or sound source of nearly same frequency, not equal frequency, nearly same frequency, that is the difference in frequency is very small but still have difference in frequency. Okay, when the two sounding bodies or two sounding source to sound of source of nearly the same frequency and amplitude, okay, are sounded together, the resultant sound consists of alternate maxima and minima. This phenomena, in which waxing and waning of sounds are happen at regular interval, is heard, is called as beats. Or known as beats. तो इस तरह की ये फिनोमिना है कि जब दो ध्वनि स्रोतों को, साउंडिंग बॉडीज को एक साथ और कैसे हों साउंडिंग बॉडीज, वो कुछ इस तरह की कंडीशन के हों तो कि उनकी फ्रीक्वेंसी सेम ना हो और एम्पलीट्यूड भी सेम ना हो, या फिर आप कह सकते हैं नियरली सेम फ्रीक्वेंसी बट नॉट एग्जैक्टली सेम, एंड एम्पलीट्यूड आर साउंडेड टुगेदर. जब एक साथ बजाए जाते हैं तो जो रिजल्टेंट साउंड होता है वो अल्टरनेट मैक्सिमा और मिनिमा रखता है, और इस अल्टरनेट मैक्सिमा और मिनिमा को हम वैक्सिंग या वेनिंग ऑफ साउंड भी कहते हैं. वैक्सिंग एंड वेनिंग का मतलब होता है उतार चढ़ाव. वैक्सिंग और वेनिंग एक्चुअली जो वर्ड है ये एस्ट्रोफिजिक्स से हमारे पास आता है, और एस्ट्रोफिजिक्स में जो चंद्रमा की कला जिसको हम कहते हैं, चंद्रमा की कला का बढ़ना और चंद्रमा का वापस अपनी कला में आना, ये जो प्रोसीजर है इसको हम वैक्सिंग एंड वेनिंग, ये वर्ड हम वहाँ यूज करते हैं. चंद्रमा का अमावस्या और पूर्णिमा को जो घटना होती है, अमावस्या को के बाद जैसे चंद्रमा अपनी कला बढ़ाता है और पूर्णिमा के बाद जैसे चंद्रमा की कला घटती है, तो वहाँ से एस्ट्रोफिजिक्स से हमारे पास वर्ड आता है वैक्सिंग एंड वेनिंग. वैक्सिंग उस प्रोसीजर को कहते हैं जब पूर्णिमा के अमावस्या के बाद चंद्रमा की कला बढ़ती है. फेज ऑफ मून हैज बीन इंक्रीज्ड, एंड वेनिंग वो प्रोसीजर है जब पूर्णिमा के बाद चंद्रमा की कला घटती है, दैट इज द फेज ऑफ मून इज डिक्रीज्ड, ओके, विद रेस्पेक्ट टू टाइम। सो वहां से ये वर्ड आया है। मतलब इसका यहाँ यूज करने का मतलब है कि द फिनोमिना इन विच वैक्सिंग एंड वैनिंग, जो चंद्रमा की कला का बढ़ना और फिर घटना, यहाँ पर क्या है, साउंड का अपनी मैक्सिमम तक जाना और फिर घटना, इसलिए ये वर्ड यहाँ यूज किया गया है, वैक्सिंग एंड वैनिंग। ओके, सो देयर इज वैक्सिंग एंड वैनिंग ऑफ साउंड एट रेगुलर इंटरवल, एक निश्चित समय अंतराल के बाद वहां उतार और चढ़ाव, किसके उतार और चढ़ाव, ध्वनि के उतार और चढ़ाव की ये जो घटना है, इसी को हम बीट्स कहते हैं, इसी को हम बीट्स कहते हैं। ओके, सो व्हेन टू साउंडिंग बॉडीज which have nearly equal frequency and amplitude are sounded together, the resultant sound consists alternately its maxima and minima, and this phenomena in which maxing and waning of sound occur at definite time interval is known as beats. Okay, the number of beats heard per second is equal to the difference in frequency between the two sound sources. जितने नंबर ऑफ बीट्स ऑफ की हम बात करें तो जितने नंबर ऑफ बीट्स पर सेकंड हम सुनते हैं वो बराबर होते हैं, इक्वल टू द डिफरेंस इन फ्रीक्वेंसी, डिफरेंस इन फ्रीक्वेंसी ऑफ साउंड सोर्स। सो हाउएवर बीट्स आर हर्ड ओनली व्हेन द डिफरेंस इन फ्रीक्वेंसी इज नॉट मोर देन 10, whatever the unit of frequency. ओके, सो डिफरेंस बीट्स केवल तभी सुनाई देंगे जब फ्रीक्वेंसी में जो डिफरेंस रहेगा कम से कम 10 का रहे, इस 10 से ज्यादा ना हो। सो इसका इसी टॉपिक का हम मैथमेटिकल एनालिसिस करने जा रहे हैं। लेट अस कंसीडर टू वेव्स ऑफ स्लाइटली डिफरेंट फ्रीक्वेंसीज n and m. n is the frequency of the first wave and m is the frequency of the second sound source or second wave, sound wave you can say it. The displacement of the particle due to these waves can be written as y1 is the displacement of the particle by the first wave or first sound source. That is y1 is equals to a sine 2 pi nt. Look at this. y1 is the displacement, a is the amplitude, sine the wave is going into the sine wave form, and 2 pi n is the frequency and t is the time. And the displacement of the second wave is represented by this equation, that is y2 is equals to a sine 2 pi mt. Look at it. The amplitudes of the two waves are same, but the frequency here is n and here is m. There is no phase difference at all between these two waves. Okay, for the phenomena of beats, or for occurring the phenomena of beats. Okay, so what is the resultant of these two waves? Now we can frequently use the superposition principle, and superposition principle says that the resultant displacement of the particle is equal to the sum of the displacement of these two, that is y1 plus y2. So the resultant displacement can be written as y is equals to y1 plus y2. So put here the value of y1 and y2 from equation number this and this. We have a sine 2 pi nt plus a sine 2 pi mt. Okay, a is common, so we have sine 2 pi nt plus sine 2 pi mt. Simply this is the formula of sine c plus sine d in trigonometry. So use trigonometry here. We have 2 cos 2 pi n minus m by 2 into t, that is 2 cos c minus d by 2, and here is sine c plus d by 2. This. So actually when sine c plus sine d, the resultant is 2 cos c minus d by 2 into sine c plus d by 2. This is the result. Okay, so on multiplying a in this bracket, we have 2a cos 2 pi n minus m by 2 into t and sin 2 pi n plus m by 2 into t. Okay, and this equation, which is equal to y, here is the equation which is equal to y, can be written as that is y is equals to a, capital A is equals to sin 2 pi n plus m by 2 into t, that is this factor, and the whole of this factor, this whole factor, this factor, this factor. This factor. So this factor is written as A, capital A. So the resultant amplitude will be, resultant displacement will be y is equals to, in place of this factor is capital A and sin 2 pi n plus m by 2 into t, this, where A is equal to 2a cos 2 pi n minus m by 2 into this factor is equal to A. Say. Now taking the first case. What is the first case? The first case is that the amplitude will be maximum, that is A is equals to plus minus 2a. Why and when? एम्पलीट्यूड अधिकतम होगा कब? जब cos 2 pi n minus m by 2 is equals to plus minus 1, जब इसकी वैल्यू प्लस माइनस 1 के इक्वल होगी। ये जो एम्पलीट्यूड है A, जो कैपिटल A एम्पलीट्यूड है, इसकी वैल्यू मैक्सिमम कब होगी? जब ये वाला जो फंक्शन है, इसमें जो cos की टर्म है, वो उसकी जो मैक्सिमम वैल्यू है वो आप जानते हैं +1 है, और जो मिनिमम वैल्यू है वो -1 है। तो अगर आप A को मैक्सिमम कहना चाहते हैं तो जो cos वाला टर्म, वट एवर द एंगल ऑफ cos, केवल आपको cos का मैक्सिमम वैल्यू देखना है, एंगल पे डिपेंड नहीं करता। तो cos के एंगल में चाहे कुछ भी हो, लेकिन जो cos की मैक्सिमम वैल्यू हो +1 होती है और जो मिनिमम वैल्यू है वो -1 होती है। तो अगर एम्पलीट्यूड मैक्सिमम करना है, इस एम्पलीट्यूड को मैक्सिमम रखना है, A इज मैक्सिमम व्हेन दिस टर्म cos 2 pi n minus m by 2 into t has a maximum value, and the maximum value of this term will be +1. So look at here. We have the maximum value of this function is actually +1, only +1, not -1, because it has value -1 also, but that's the minimum value of cos, whatever the angle of cos. So cos 2 pi n minus m by 2 into t, the maximum value of cos is +1, and that's why A is maximum in this case. And what is the कि इस फंक्शन का जो मैक्सिमम वैल्यू है +1, तो cos के किस एंगल में वैल्यू +1 होती है? तो +1 जो वैल्यू होती है वो 0, पाई, 2 पाई, 3 पाई, 4 पाई, या फिर मैं कहूँ n पाई में जो वैल्यू है वो प्लस या -1 ये देता है। सो this angle can be written as k pi, and you can, because हम इसको जनरली n पाई लिखते हैं, लेकिन n हमने इस फ्रीक्वेंसी को पहले से ही कंसीडर किया है, इसलिए मैं इसको लिख रहा हूँ k पाई। सो यहाँ से 2 से 2 कैंसिल हो गया, पाई से पाई कैंसिल हो जाएगा। तो जो यहाँ से t का वैल्यू आएगा, वो आएगा k over n minus m, which is equal to 0, 1 over, not equal to 0, the next one value is this, if k has these values. So when we put the value 0, so it gives me 0. When you put the value 1, it gives me 1 over n minus m. When you put the value 2 of k, this gives me 2 over n minus m. And so when we put the value of k is 3, then this term will be 3 over n minus m, and so on. ये ऐसे ही चलता रहेगा. Hence the time interval between the two consecutive maxima is 1 over n minus m. Okay, subtract this from this, gives you n minus m. 1 over n minus m. Subtract this from this, this gives again you 1 over n minus m, and subtract this from this, then again you will get 1 over n minus m. So the time interval, because this is equal to t, that is the time interval between the two consecutive maxima, should be 1 over n minus m. Okay, so the frequency of the maxima, because frequency is always the reciprocal of time period, so time period is this, then the frequency is equals to n minus m, reciprocal of this quantity. Okay, so if we have two waves which have slightly different frequency, and the resultant amplitude of the resultant displacement of the two waves is shown by this equation, and this equation can be written as in this form, where A is this. Then in the case first, we conclude these results, that is the time interval between the two consecutive maxima, or you can say it as the time period is equals to 1 over n minus n, and so why the frequency of maxima is equals to n minus m. That is the difference between the two frequencies. Okay, now let us talk about the second case, when the amplitude will be minimum. कब? यानी a equals to 0 होगा. कब? यहाँ देखिए, ये इक्वेशन मुझे देता है एम्पलीट्यूड ऑफ द two waves, resultant amplitude of the two waves, whose displacement is given by this equation. This equation gives me the resultant amplitude. Okay, and the resultant amplitude A is minimum, and the minimum value is 0. Minimum value of amplitude is 0. Maximum is +1, or into the minus side is -1. So the maximum value will be +1 or -1, but the minimum value will be 0. So this value will 0 when the cos this function, the angle of cos will be pi by 2, and should be pi by 2. Actually should be pi by 2. ओके, इसका वैल्यू मिनिमम कब होगा? और मिनिमम वैल्यू मैं कह रहा हूँ 0 है, तो ये वैल्यू 0 कब होगी? जब कोस के एंगल में इस एंगल की जगह क्या हो? पाई बाई 2. तब ये वैल्यू क्या हो जाएगी? 0, बिकॉज कोस पाई बाई 2, कोस 90 मुझे क्या देगा? 0. सो दिस एम्पलीट्यूड विल बी मिनिमम और 0 व्हेन कोस हैज an angle pi by 2. So look at here. This, the amplitude will be minimum. A will be 0 when cos 2 pi n minus m by 2 equal to 0, or cos has this value, k pi plus pi by 2, where k is equals to 0, 1, 2, 3. अब ये क्वेश्चन यहाँ आना नेचुरल है दिमाग में कि ये वैल्यू हमने डायरेक्ट पाई बाई 2 क्यों नहीं लिख दी, या फिर हम इसको अगर जनरली फॉर्म में लिखना चाह रहे थे तो हमने इसको k पाई बाई 2 क्यों नहीं लिख दिया? इसका रीजन ये है कि अगर मैं इस वैल्यू को k पाई बाई 2 लिख देता, अगर हम इस वैल्यू को k पाई बाई 2 लिख देते, तो रीजन समझिए कि अगर k का वैल्यू 0 है तो ठीक है, ये एंगल पाई बाई 2 ही बना रहा. फिर हमारे पास ये जो वैल्यू है ये 1 रह गई. मान लीजिए मैं इसको k पाई बाई 2 लिख देता, k पाई बाई 2, ओनली k पाई बाई 2, यानी मैं इस इक्वेशन को लेट अस डू हियर इट, द एम्पलीट्यूड हैज वैल्यू दिस 2a cos 2 pi n minus m by 2 into 3. This is the resultant amplitude of the two sound waves which have slightly different frequency. This is the resultant amplitude, and this resultant amplitude will be minimum, that is equals to 0 when 2a cos 2 pi n minus 1 by 2 is equal to 0, because 2a does not equal to 0, because these are the constants which never be equal to 0. So cos 2 pi n minus m by 2 into t will be equal to 0, and that's why will be equal to 0. And I can simply write it here as what is the value of cos, or you can say it as what is the angle of cos in which cos has 0 value. So you can say it as cos k pi by 2, where k has value 0, 1, 2, as extra, as extra. So simply you can say it that this angle will be equal to this angle, or you can say it as 2 pi, you can say it as 2 pi n minus m by 2 into t is equals to k pi by 2. If I write it in this way, so what is the difficulty to writing this equation in this way? I explained that one. So where k has 0, 2, 3 as extra values. So look at the problem. Okay, when k has 0 value, okay, no problem. The equation is, because here is cos, here is cos, okay, no problem. So cos 0, yani when we put k equals to 0, so this angle will be 0. So cos 0, and cos 0 has value +1. But the +1 value is when the amplitude is maximum. एम्पलीट्यूड इज मैक्सिमम. ये वैल्यू कब है एम्पलीट्यूड की? +1 वैल्यू कब है? यहाँ देखिए, लुक एट हियर, look at here, this a is maximum when cos has value +1 or -1, you can say it as, okay. +1 और -1 मैं इसलिए कह रहा हूँ क्योंकि जब इस तरह का साइन वेव ट्रेवल करता है तो जो पॉजिटिव साइड पे वैल्यू रहती है वो +a रहती है, और जो नेगेटिव साइड पे वैल्यू रहती है वो -a रहती है, इसलिए वो +1 और माइनस वाला सीक्वेंस यूज किया गया है. लेकिन मैं मिनिमम वैल्यू के ऊपर बात कर रहा हूँ. लेकिन जब cos की वैल्यू मैं 0 यहाँ पुट करता हूँ तो ये बन जाता है cos 0, और cos 0 देता है +1 वैल्यू, यानी इस टर्म की वैल्यू हो जाएगी +1, और ये टर्म +1 वैल्यू कब देगा? जब इस cos की वैल्यू मैक्सिमम रहेगी. लेकिन हम तो केस मिनिमम का डिस्कस कर रहे हैं, इसीलिए जो cos का एंगल है उसको ऐसे लिखा गया है k पाई प्लस पाई बाई 2. यानी अगर आप यहाँ 0 भी डालते हो, 0 डालते हो, सो ये वैल्यू हो गई 0, स्टिल द एंगल इज पाई बाई 2. 1 डालते हो तो 1 यहाँ रखिए, सो पाई प्लस पाई बाई 2 दैट इज 3 पाई बाई 2. तो वैल्यू इज ऑलवेज इनटू द एंगल ऑफ cos, in which cos has value always 0, in which cos always has value equal to 0. Put here 1, so pi plus pi by 2, result is 3 pi by 2, and cos 3 pi by 2 is 0. Put here 2, so 2 pi plus pi by 2, 2 to the 4 plus 1, that is 5 pi by 2. So cos 5 pi by 2 is always 1, always 0. So this angle should be such that the cos always has value 0 in this angle. That's why we cannot write it as cos k pi by 2, as cos k by 2. Okay, that's why this angle is written in this form, k pi plus pi by 2. So why we can maintain this term in the form of pi by 2 angle. You can say it as pi by 2 angle. Okay, so in this equation cos 2 pi n minus m by 2 into t is equals to 0, and in this angle cos has always 0 values with these conditions, that is when k has value 0, 1, 2, 3 up to. Okay, now 2 is cancelled with 2 and the equation becomes pi n minus m by into t is equals to pi is common from here. So this equation becomes k plus half, pi is cancelled with pi, and from this equation we can calculate the value of t. So t is equals to k over n minus m, that is this quantity is into the denominator of k, so gives you k over n minus m, plus is this sign, and half is here, so half of n minus m, because this quantity goes into the denominator. So this is the value of t, that is the time period when the amplitude is minimum, is of this form. And you know that k has value 0, 1, 2, 3 up to. So put here the value 0. So put 0 here. So this term will be 0. We are left with only this term 1 over 2 n minus m. And when you put value k is equals to 1. So k is equals to 1. So 1 over n minus m plus 1 over 2 n minus m. So result is 3 over 2 n minus 1 and up to. The next one is when k is equals to 2. When k is equals to 3, the next value is, actually k is equals to 2. The value is 5 over 2 n minus m and up to. So the time interval between the two consecutive maxima, so subtract this from this. Let us see here. 3 over n minus m minus 2 over n minus m is equals to, because denominator is same, so subtract the numerator and we have 3 minus 2 is equals to 1. That is the time interval between the two consecutive minima, and this will be equals to the time period t. So why frequency? Because n is the reciprocal of time period, so reciprocal of this quantity will be n minus m. So look at these two results. Frequency of minima n minus m and frequency of maxima n minus m. Look at these two results. Frequency of minima will be n minus m and frequency of maxima will be n minus m. Hence, since one maxima and one minima of sound constitutes a beat, the number of beats will be n minus m per second. Thus, the number of beats produced per second is equal to the difference in frequency of the two sound waves. This difference in the frequency of two sound waves. So this is all about the superposition of two collinear harmonic oscillation of different frequency. In the previous lecture, in the last lecture, we were discussing about a case where the superposition of two collinear harmonic oscillations with the same frequency. Okay, so let us move forward and start a new topic. So this topic is about the superposition of two perpendicular हार्मोनिक ऑसिलेशन हैविंग फ्रीक्वेंसी 1:1. सो केस में क्या डिफरेंस है? जो पहला केस हम स्टडी किया पिछले लेक्चर में, उसमें सुपरपोजिशन ऐसी दो वेव्स का सुपरपोजिशन था, ऐसे दो हार्मोनिक ऑसिलेशंस का सुपरपोजिशन था जिनकी फ्रीक्वेंसी इक्वल थी लेकिन दोनों एक ही डायरेक्शन में जा रहे थे. अब जो अभी हम केस स्टडी करके आए हैं वो दो ऐसे हार्मोनिक ऑसिलेशंस थे जिनके बीच में फ्रीक्वेंसी सेम नहीं थी. अब जो केस हम स्टडी करेंगे वो ऐसे दो हार्मोनिक ऑसिलेशन का सुपरपोजिशन है जो एक दिशा में नहीं जा रहे बल्कि एक दूसरे से राइट एंगल हैं, परपेंडिकुलर टू ईच अदर, परपेंडिकुलर हार्मोनिक ऑसिलेशंस. यानी एक को अगर आप एक्स डायरेक्शन में कंसीडर करते हैं तो दूसरे का जो डायरेक्शन ऑफ प्रोपेगेशन है वो वाई रहेगा. यानी यहाँ हम कुल मिला के 4 केस स्टडी करने वाले, और 4 में से जो पहला केस हम स्टडी किया था, जो पिछले लेक्चर में हमने स्टडी किया था, वो ये था कि हमारे पास दो वेव्स थी दो वेव्स थी इस तरह से जो एक ही डायरेक्शन में जा रही थी और दोनों की जो फ्रीक्वेंसी थी वो सेम थी। अभी जो केस हम स्टडी करके आए हैं वो सिमिलरली यही था, इसी तरह की दो वेव्स थी, लेकिन दोनों की फ्रीक्वेंसी में अंतर था, फ्रीक्वेंसी में डिफरेंस था, डिफरेंट फ्रीक्वेंसी। तो कल जो हमने लेक्चर स्टडी किया वो ये था, दैट इज द सुपरपोजिशन ऑफ टू सिंपल हार्मोनिक ऑसिलेशंस हैव सेम फ्रीक्वेंसी। अब जो हमने आज के लेक्चर में अभी तक स्टडी किया वो ये वाला केस था, दैट इज द सुपरपोजिशन ऑफ टू हार्मोनिक ऑसिलेशंस विच हैव डिफरेंट फ्रीक्वेंसी। अब जो हम केस स्टडी करने जा रहे हैं वो है कि अब हमारे पास दो ऐसे हार्मोनिक ऑसिलेशंस हैं जो अगर एक वेव का जो प्रोपेगेशन है वो एक्स डायरेक्शन में है तो जो दूसरी वेव का प्रोपेगेशन है वो वाई डायरेक्शन में है। यानी अगर इसको आप एक्स एक्सिस कहें और इसको आप वाई एक्सिस कहें तो दोनों का वेव का जो है जो प्रोपेगेशन है वो एक दूसरे से परपेंडिकुलर है, ये वाला केस। लेकिन ये दो वेव के साथ एक कंडीशन है कि इनकी जो फ्रीक्वेंसी है वो सेम एन, यानी जो फ्रीक्वेंसी है वो सेम है। और अगले वाला जो केस स्टडी हम करेंगे वो इस तरह का केस होगा कि कंडीशन ये रहेगी कि दोनों वेव एक दूसरे के परपेंडिकुलर है, दोनों ऑसिलेशंस एक दूसरे के परपेंडिकुलर, लेकिन जो फ्रीक्वेंसी है वो डिफरेंट है। जो फोर्थ केस रहेगा वो ये रहेगा। तो अभी जो थर्ड केस हम स्टडी करने जा रहे हैं, यू कैन मैनेज इट नाउ, दैट द फर्स्ट केस इज दैट व्हेन द टू हार्मोनिक ऑसिलेशंस ऑफ सेम फ्रीक्वेंसीज इज प्रोपेगेटिंग in the same direction. The second case, as we discussed earlier in this lecture, that the two harmonic oscillations or two harmonic SHMs, simple harmonic motions, which have different frequencies, are propagating into the same direction. In this case, we will discuss about a case when two harmonic oscillations are into the direction of propagation of the two simple harmonic oscillations are perpendicular to each other, but they have same frequency. Okay, direction same, frequency same. Direction same, frequency different. Direction different, frequency same. That is the difference between these two cases, these three cases. And in the fourth one there is another difference. Okay, so let's first concentrate on this superposition of two superposition of two perpendicular harmonic oscillations having frequency ratio 1:1. Okay, so first define the Lissajous figure. What is Lissajous figure? Okay, so when a particle is acted upon simultaneously by two simple harmonic motion at right angle to each other, the resultant path traced out by the particle is called Lissajous figure. जब दो पार्टिकल, कोई एक पार्टिकल simultaneously acted upon by two simple harmonic motions at right angle to each other, the resultant path traced out by the particle is called as Lissajous figure. The shape of the resultant path or figure depends on the time period, phase difference and amplitude. तीन बातों पर निर्भर करती है, टाइम पीरियड यानी आवर्तकाल, फेज डिफरेंस यानी कलांतर और एम्पलीट्यूड यानी आयाम। उन दो वेव के जो लिसाजियस फिगर का जो रिजल्टेंट होगा, रिजल्टेंट पाथ जिसको हम लिसाजियस फिगर भी कहते हैं, वो तीन बातों पर निर्भर करता है। टाइम पीरियड क्या है वेव का, फेज डिफरेंस क्या है दोनों के बीच में, और एम्पलीट्यूड क्या है। यानी ये बात कुछ आप इस तरह से समझ सकते हैं कि मान लीजिए आपके पास इस तरह की दो वेव्स हैं जो एक इस डायरेक्शन में मूव कर रही है और दूसरी इस डायरेक्शन में। इसको मैं एक्स एक्सिस कह रहा हूँ और इसको मैं वाई एक्सिस कह रहा हूँ, और यहाँ कोई पार्टिकल है इन दोनों एक्सिस के बीच में। तो इस पार्टिकल का एक वेव यहाँ मूव कर रही है एक्स एक्सिस पे तरह से, और दूसरी वेव यहाँ मूव कर रही है वाई एक्सिस पे। और ये जो रिजल्टेंट पाथ होगा इस पार्टिकल ड्यू टू द मोशन ऑफ दीज टू वेव्स विच इज नोन एज लिसाजियस फिगर, विच इज नोन एज लिसाजियस फिगर। और ये जो लिसाजियस फिगर है या पाथ है इस पार्टिकल का जो ट्रेस्ड होगा वो तीन बातों पर निर्भर करता है। एक टाइम पीरियड पर, टाइम पीरियड कैसा है दोनों वेव का, दूसरा दोनों वेव्स के बीच में फेज डिफरेंस कितना है, और तीसरा एम्पलीट्यूड कैसा है, दोनों वेव्स के बीच में एम्पलीट्यूड कैसा है, इक्वल एम्पलीट्यूड है या नहीं, टाइम पीरियड इक्वल है या नहीं, फेज डिफरेंस है या नहीं। इन बातों पर, इन तीन बातों पर ये जो रिजल्टेंट फिगर होगी जिसको हम लिसाजियस फिगर कह रहे हैं ये डिपेंड करेगी। ओके, सो हम पहला केस स्टडी करने जा रहे हैं जब दो हमारे पास वेव्स हैं जिनकी फ्रीक्वेंसी का रेशो 1:1 है। द रेशो ऑफ फ्रीक्वेंसी बिटवीन द टू वेव्स इज 1:1. Okay, so let's start it. Let the two simple harmonic motions of equal frequencies, और equal frequency का मतलब ये हुआ कि equal time period and wavelength हुआ, equally wavelength होगी, equally time period होगा, be along the x and y axis because these are two perpendicular, the propagation of waves are in the direction of two perpendicular axes. One is, if one is in the x-axis, the other is into the y-axis. If one is into the y-axis, the other into the x-axis. Because we are dealing in the two-dimensional coordinate, so there is no need to discuss about third coordinate, that is the z-axis. So, if their displacement at any instant t be x and y, why x and y? Because in the syllabus we have covered so far, we have always take the displacement is equals to y, because we always consider that the wave is propagating into the direction of y. But here in this case we have two waves which are perpendicularly propagate to each other. One, if we consider one into the direction of x-axis, the other is into the direction of y-axis. That's why the displacement is considered as x and y, because the propagation is into the direction of x-axis and y-axis. For the wave which is propagated into the direction of x-axis, the displacement is considered as x, and for the wave which is propagating into the direction of y-axis, the displacement is considered as y, small y. Okay, so the displacement is represented as x equals to a sine omega t. A is the amplitude of the wave, and y is equals to b sine omega t plus phi. This is equation number 2. So look at these two equations. Displacement into the direction of x-axis, displacement into the direction of y-axis, amplitude of the first wave which is propagating into the direction of x-axis has amplitude equals to a, and the wave which is propagating into the direction of y-axis has amplitude equal to p. The two waves are of the form of sine wave and equal frequency. Omega is equals to omega, so have equal frequency because omega is equals to 2 pi n, and n because the frequency is same, so omega is equals to omega, and there is also a phi, that is the phase difference between the two waves. So the different components of the waves are displacement are different, amplitude are different, phase are different, but frequency is same, because omega is omega in the two equations, equation number 1 and equation number 2. That's why frequency same and all the other components, that is displacement, amplitude and phase, are different. Okay, so from equation number 1, use equation number 1, we have sine omega t is equals to x over a. You can see sine omega t is equals to a. This, use this equation and calculate the value of sine omega t from here. So sine omega t equal to x over a, x over a. And from this equation, from this result, we can deduce the value of cos omega t. How we can deduce the value? Because sine omega t has value x over a. Okay, and you know that we want to find the value of cos omega t. So we can write cos omega t as 1 over 1 minus sine square omega t. This cos theta is equals to root 1 minus sine square theta. 1 minus sine square theta is cos square theta. Square is cancelled with the square root and you can get the cos theta. So because here is angle is omega t, so you can write this equation because we have formula cos square theta plus sine square theta is equals to 1. And you want to calculate this value. Cos square theta is equals to 1 minus sine square theta, because this sign is onto the right hand side will become minus. So calculate the value of cos theta from here, because this has square, so cos theta is equals to square root of 1 minus sine square theta. Yes. So similarly, if the angle is omega t, so cos omega t is 1 minus sine square omega t. This 1 minus sine square omega t. So this, and because sine omega t has value x equal to a, so we have cos omega t is equals to 1 minus x square over a square. This. So cos omega t has value this, root 1 minus x square over a square. Look at here. This. Cos omega t is equals to root 1 minus x square over a square. Okay, and from equation number 2, this equation, we have y over b. So y over b is equals to sine omega t plus phi. This, and sine omega t plus phi can be expanded as, because this is the formula of sine a plus b, and the sine a plus b gives me sine a cos b plus cos a sine b. So sine a cos b plus cos a sine b. In place of a there is omega t, and in place of phi there is b. In place of b there is phi. Okay. So this is equation number 3. On substituting the value of sin omega t and cos omega t in equation number 3, यहाँ से जो आपके पास sin ओमेगा t की वैल्यू है दैट इज x ओवर a, और cos ओमेगा t की जो वैल्यू है रूट 1 माइनस एक्स स्क्वायर ओवर a स्क्वायर, इनको यहाँ से उठाइए और इक्वेशन नंबर 3 में पुट कर दीजिए. सो वी हैव द लेफ्ट हैंड साइड इज सेम y ओवर b, the value of sin omega t is x over a, so put here x over a, and cos phi is same, plus sin is same, cos omega t, and cos omega t has value root 1 minus x square over a square, so put here in place of cos omega t root 1 minus x square over a square, and sin phi is same, sin phi is same. Okay, so this, and let us rewrite this equation as y by b is same on the left hand side, and x over a cos phi is gone on to the left hand side, so this will become with negative sign y over b, and this term is going on to the left hand side will become a minus term, so x over a cos phi is equals to root 1 minus x square over a square, and sin phi is same. Sin phi is same. Okay. Now squaring both sides. So square of this whole term, because this is the square of a minus b whole square. So y minus b minus x over a cos phi whole square, and whole square of this whole term, whole square of this term. So let us solve this. So because we have a minus b whole square onto the left hand side, and onto the right hand side we have square root of 1 minus x square over a square. So because this is the whole square, so square is cancelled with the square root, and this quantity will become 1 minus x square over a square, and the square of sine phi is sine square phi. So let us see this term. So this term is here. Y minus b minus x over a cos phi whole square, and is equals to 1 minus x square over a square sine square phi. This is because square is cancelled with the square root, and the square of sine is sine square phi, and the left hand side is same. So let us expand this square. This is actually the square of a minus b. In place of a we have y over b, and in place of a we have y over b, and in place of b we have x over a cos phi. So let us expand it, because you know that the square of a minus b whole square, the expansion is a square plus b square minus 2ab. So let us expand it. And we have expansion of this y square over b square a plus x square over a square cos square phi, and minus 2ab. Multiplication of these two terms will result in this term is equals to multiply the sine square phi into the bracket. So when the sine square phi is multiplied by 1, it gives you sine square phi, and multiplication of this sine square phi with this term gives you x square over a square sine square phi is equals to 0. This term. So y square over b square is same, this term, minus 2xy by ab cos phi, this term is same, but this term, look at this term, x square by a square cos square phi, and look at this term, x square by a square sin square phi. But this term onto the right hand side, and this is not 0. Onto the right hand side, and when this term comes onto the left hand side, this will be positive. So because x square over a square is common from this term, so this term, when x square over a square is common, then there is left only cos square phi, this cos square phi, and this minus will become, when this term is come onto the left hand side, minus will become positive. So x square over a square is common, and sin square phi is as it is, minus this term sin square phi, because this whole term is gone onto the left hand side. Okay, so y square over b square minus 2xy over ab cos phi, these first two term is same, and cos square phi plus sin square phi, by the trigonometric formula this will become plus 1. So x square over a square and x square over a square is equals to sin square phi. This is equation number 4th. So this represents the resultant motion of the particle. This is the resultant motion of the particle, with, or you can say it of a motion of wave, the resultant of two waves, by which, or you can say it as the resultant of two waves in which one wave is traveling at the x-axis and the other is traveling at the y-axis. One is traveling at the x-axis and other is traveling at the x-axis. That is, the direction of propagation is perpendicular to each other. Amplitudes different. There is a phase difference, but of same frequency. Frequency is same. That means time period is same, and wavelength is same. Okay, so this is the resultant of those two waves, these waves. One is traveling towards x-axis, other is traveling towards y-axis. Say amplitudes are different, there is a phase difference between the two waves, but frequency is same. frequency is same. So by the superposition of these two waves, the resultant wave will be of this type: y square over b square minus 2xy over ab cos phi plus x square over a square is equals to sin square phi. This is equation number 4. Okay, this equation represents the resultant motion of the particle or the wave, which is in general an ellipse inclined to the axis coordinate. इलिप्स का एक इक्वेशन है. इसके स्पेशल केसेस के बारे में अभी हम डिस्कस करेंगे कि कौन कौन से इसमें स्पेशल केसेस हो सकते हैं. सो लेट अस स्टार्ट दैट. स्पेशल केसेस व्हेन फाई इक्वल टू 0. अगर ये जो फेज डिफरेंस है, ये वाला फेज डिफरेंस जो इनिशियली इन दोनों वेव्स के बीच में था, ये वाला जो फेज डिफरेंस है, अगर ये 0 हो जाए तो व्हाट हैपेंड देयर? सो व्हेन फाई इक्वल टू 0, that means sin phi will be 0 and cos phi will be 1, because sin 0 0 and cos 0 1. So put these values into this equation number 4. We have y square over b square minus 2xy over ab, because cos phi is equals to 1, because phi is equals to 0, plus x square over a square, and the right hand side will become 0, because sin phi is equals to 0 and sin 0 has value 0. Okay, and look at this equation: y square over b square minus 2xy over ab plus x square over a square is equals to 0. That means this will become the whole square of this y minus b minus y over b minus x over a to the power 2. That is the whole square of this term. And look at this bracketed term. Although this is the square term, but it's still equal to 0. That is we can write this equation as y over b minus x over a into y over b minus x over a is equals to 0. That means we can write this equation as y is equals to b over a into x, and that is the y is equals to mx type equation. That is the equation of a straight line. That is the equation of a straight line which have slope is equals to b over a. That is the value of tan theta is b over a, because y is equals to mx and m has value equal to tan theta. M is equals to tan theta into the equation of a straight line. You can study this in the high school standard. Y is equals to mx. ये वाला जो इक्वेशन है, ये या फिर ये दोनों, चूंकि स्क्वायर्ड टर्म है तो हम इसको ऐसे भी लिख सकते हैं. तो इनमें से ये वाली इक्वेशन या फिर ये वाली इक्वेशन दोनों एक स्ट्रेट लाइन की इक्वेशन है. यानी जो रिजल्टेंट पाथ है, जब दोनों वेव्स के बीच का फेज डिफरेंस 0 होगा, तो जो रिजल्टेंट पाथ होगा उस पार्टिकल का या फिर जो रिजल्टेंट वेव होगी, वो एक स्ट्रेट लाइन पर ट्रेवल करेगी. या वो जो पार्टिकल जिसके बारे में हम डिस्कस कर रहे थे, जो दोनों एक्सिस के बीच में था, या फिर उस प्लेन में आप कह सकते हैं कि एक्स वाई प्लेन में था, उस पार्टिकल का जो रिजल्टेंट मोशन होगा वो एक स्ट्रेट लाइन में होगा. ओके, सो दस द रिजल्टेंट मोशन ऑफ ए मोशन इज अ पेयर ऑफ co-incident straight line pair, because of this square. Pair of coincident straight lines lying in quadrant first and third. Lying in quadrant first and third of rectangles as shown. This is a rectangle. Okay, and this is the first quadrant of rectangle. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. So the straight line path of the particle is in this straight line. When we draw the Lissajous figure, okay, this path will be exactly same when we draw that figures. In the coming lectures, we will try to draw Lissajous figure to corresponding these quantities, that is when amplitude is different, when amplitude is same, when phase difference is different, when phase difference is same, when frequency is different, when frequency. Although in this case we are only concentrated about a case where the difference in the frequency of the two waves will be same. Okay, but that is, there is no difference between the frequency of the two waves, or we can say it as simple that the two waves are of same frequency. But in the coming lectures, we are discuss the cases where there is a difference in the frequency of the two waves. And what is the resultant of that waves are traced or can be traced by Lissajous figure. Okay, so let us left this figure for that case. When we draw Lissajous figure, you can obtain the same straight line in first quadrant as well as in the third one. Let us move forward and discuss yet another case. That is a straight line inclined at angle theta to the x-axis, which is given by tan theta b. Tan theta is equals to b by a, because this tan theta m y equal to mx. Compare these two equations. M is equals to b by a, and m is also equals to tan theta. The phase difference, the resultant phase difference between the two waves is given by this equation. The resultant phase difference of the two waves is given by this equation. Okay, let us discuss yet another case when the phase difference between the two waves is pi by 4, 45 degree, or you can say pi by 4 radian or 45 degree. So when the phase difference between the two waves is about 45 degree, so cos 45 is equals to 1 over root 2 and sin 45 is equals to 1 over root 2. The two sine and cosine has same value into when the angle or when the angle in the sine function or cos function is 45. So these two terms, the trigonometric terms, has same value 1 over root 2 and 1 over root 2. So put these value, the cos pi by 4 when phi is equals to pi by 4 and sin pi by 4 is 1 over root 2 into the equation number 4th, this equation, into this equation, equation number 4th. Y over b square minus 2xy over ab cos phi plus x square over a square is equals to sin square phi, this. So when we put these results into that equation, equation number 4th, we have y square over b square minus 2xy over ab cos phi. So cos phi has value 1 by root 2 plus x square over a square is equals to sin square phi. So sin phi has value 1 by root 2 and the square of this gives you 1 by 2. So y square over b square minus root 2, because 2 is cancelled with 2, so root is here, root 2 xy over ab plus x square over a square is equals to 1 by 2. This equation represents an oblique ellipse as shown. This equation represents an oblique ellipse. This is a rectangle, has value this side 2a and this side 2b, and this oblique ellipse lies in first and third quadrant mainly. Okay. When phi is equals to pi by 2, cos phi is 0, because cos pi by 2 is 0 and sin pi by 2 is equals to 1. So put again these value into that equation, equation number 4th. We have y square over b square minus 2xy ab into 0, because here is cos phi and cos phi is cos pi by 2 and cos pi by 2 equal to 0. So is 0. X square over a square is same, is equals to square of this sin square phi, and sin phi is sin pi by 2, sin pi by 2 is 1, and the square of 1 is gives you 1. So y square over b square plus x square over a square is equals to 1. This equation represents an ellipse where the major axis and minor axis are coincides with the coordinate axis as shown. This is an ellipse. This side is 2a of this rectangle and this side is 2b, that is the length of the rectangle is 2a, which is equal to the major axis of this ellipse, and breadth of the rectangular is equal to the minor axis of this ellipse, Okay, and in the same way In the same way, you can put phi is equals to 3 pi by 4. You can get an oblique ellipse. You can get an oblique ellipse lies mainly into the second and fourth quadrant. And when phi is equals to pi, you can again get a pair of coincident lines lying into the second and third quadrant. Okay, and if in this case, if the A is equals to B, that is the minor axis and the major axis of the ellipse is equal to 0, then you can get the equation of a circle. This, when A is equals to B and phi is equals to pi by 2. But phi is equals to pi by 2 is still there, but when A is equals to B. So y square over A square and x square over A square. So x square plus y square is equals to A square. This equation represents a circle of radius A and diameter 2A. So these are the conclusion of all the figures we have according to the phase difference between the two waves which have propagating perpendicular to each other, have different amplitude and different phase. So when phase difference between the two waves, the resultant path of the particle is a straight line again into the first and third quadrant. When phi is equals to pi by 4, that is the phase difference between the two waves which are perpendicularly propagate to each other, having different amplitude, different phase, same frequency. So the resultant path of the particle will be an oblique ellipse, lies in first and third quadrant. When phi is equals to pi by 2, the resultant path of the particle will be an ellipse. When phi is equals to 3 pi by 4, the resultant path of the particle will be an ellipse lying into the second and fourth quadrant. And when phi is equals to pi, again the path of the particle is equal to a pair of a straight line which lying mainly into second and fourth quadrant. And again, when we increase the phase difference, that is phi is equals to pi by 4, again an ellipse lying into the second and fourth quadrant. Phi is equals to 3 pi by 2. When the phase difference is this, then the resultant path of the particle is an ellipse. When phi is equal to 7 pi by 4, the resultant path of the particle will be an ellipse, which is exactly same to this case. And this case is exactly same to this case. This case is exactly same to this case. And when we increase the phase difference between the two waves, phi is equals to 2 pi, then the resultant path of the particle will be a pair of a straight line. And this case is exactly coincide with, no, it is not coincide. The direction, although this straight line and this straight line lying into the second and first and third quadrant, and this is also into the first and third quadrant. So this will be resembled with this. So according to phase difference, the resultant path of the particle will be different. So these all figures are called Lissajous figure. The resultant path or resultant trajectory of a particle according to the phase difference between the two waves which are perpendicularly travel to each other is known as Lissajous figure, and these are the some Lissajous figure of the wave which have same frequency. Okay, so that's all for now, and meet you into the next one. Thank you.